Let's look at what we call the discriminant. So if you have a square, if you square any real number, the result will be greater than or equal to 0. So this means that if you have, say, a value y that is negative, if y is negative, this implies that root of y cannot be a real number. If y is negative. So let's look at the quadratic formula, which is x is equals to minus b plus or minus root of b squared minus 4ac over 2a. Now, if the value in this square root sign is a negative, if this b squared minus 4ac is a negative, then that means x cannot be a real number, and there are no real solutions for this. If the value under the square root is equals to 0, then both solutions will be the same if this is 0. So for our quadratic function, f of x is equals to ax squared plus bx plus c. The expression, which is b squared minus 4ac, this is what we call the discriminant. Now the value of the discriminant shows how many roots that f of x has. For example, if you get b squared minus 4ac, if this here is greater than 0, then that implies that f of x has two distinct real roots. If b squared minus 4ac, the discriminant, if it is equals to 0, then f of x, that means f of x has one repeated root. But if the discriminant b squared minus 4ac is less than 0, then that means that f of x has no real roots. So the graphs will look something like this. So if you have y being equals to f of x, so if y is equals to f of x, where f of x is equals to is a quadratic, then if if the discriminant is greater than 0, that means we said we have two distinct real roots. So the graphs, it will look something like this. So this is y and this is x. Then it could also look something like this. So it has two distinct real roots. It will have this root and this root. Then where the discriminant is equals to 0, we said it has one repeated root. So that graph is like this. So it has a repeated root, which is like that. Then where the discriminant is less than 0, we said that it has no real roots. So the graph will be something like this. It has no x value. It has no exact real root. Let's look at an example. They've told us to find the values of k if f of x is equals to x squared plus kx plus 9, which is equals to 0. So we have x squared plus kx plus 9 is equals to 0. So this is our quadratic equation. Now in this case, our a value is 1, our b is k, and our c is 9. So we replace these here in the discriminant, which is b squared minus 4ac. So for equal roots, b squared minus 4ac has to be equals to 0. So we've said our b is k, so it will be k squared minus 4 times a, which is 1, times c, which is 9, is equals to 0. So we shall have k squared minus 4 times 1 times 9 is 36, is equals to 0. Therefore, we shall have k squared, when this crosses to this side, which will become plus positive 36. So you have to use the condition given in the question to write the statement about the discriminant. In our question, we were told that the quadratic is equals to 0. So that's why we said b squared minus 4ac is equals to 0. That means we have to get two equal roots if it is equals to 0. So k squared is equals to 36. Find the square root on both sides. So k will be equals to plus or minus 6. So it has 6 and then negative 6. So those are the values of k. Let's look at this other question, which is find the range of values of k for which x squared plus 4x plus k is equals to 0 has two distinct real solutions. So our quadratic is x squared plus 4x plus k is equals to 0. Now here our a value is 1, b is 4, and c is k. Now for two real solutions, that means the discriminant b squared minus 4ac has to be greater than 0. That's when we get two distinct real solutions. Therefore, substitute for b, a, and c. So we said our b is 4, so 4 squared minus 4 times a, which is 1, times c, which is k. This should be greater than 0. So we shall have 4 squared is 16 minus 4 times 1 is 4, 4 times k is 4k. This should be greater than 0. So we shall have 16 being greater than, this comes to this side to become positive 4k. We divide both sides by 4. So this becomes 4 is greater than k. So if you flip it, this implies that k is less than 4. So this implies that for any values of k that are less than 4, that implies that the equation will have two distinct real solutions. So now, the graph of a linear equation and the graph of a quadratic equation can either intersect twice. So that means they can intersect twice. That is, we're talking about a linear equation, the graph of a linear equation and the graph of a quadratic equation. They can either intersect twice or they could intersect once or not intersect at all. So after substituting, you can use the discriminant of the resulting quadratic equation to determine the number of points of intersection. So for a pair of simultaneous equations that produce a quadratic equation that is of the form ax squared plus bx plus c is equals to 0, if the discriminant b squared minus 4ac is greater than 0, this means it will have two real solutions where the graph will, so the linear equation graph and the quadratic equation graph, they will intersect in this way. Then where the discriminant is equals to 0, here we will have one real solution, so the graph will be something like this. Then where the discriminant is greater than 0, then there we have no real solutions. So they will not intersect at all, the linear graph and the quadratic graph. They will not intersect at all. Now let's look at this example here, or this question. The line with the equation y is equals to 2x plus 1 meets the curve with the equation kx squared plus 2y plus, into brackets, k plus 2 is equals to 0 at exactly 1 point. So they meet at exactly 1 point. Given that k is a positive constant, so you have to take note that we've been given the condition that they meet at exactly 1 point. So given that k is a positive constant, A, find the value of k, and then B, for this value of k that you've found, find the coordinates of the point of intersection. So the equation of the line, they've told us it's y is equals to 2x plus 1. And the equation of the curve, we've been told, is k x squared plus 2y plus k minus 2 is equals to 0. So this is our equation 1 and this is our equation 2. Now let us substitute y in equation 2. Let us substitute y, which is 2x plus 1, into equation 2. So we shall have k x squared plus 2 into 2x plus 1 plus k minus 2 is equals to 0. This is equals to kx squared plus 2 times 2 is 4x plus 2 times 1 is 2 plus k minus 2 is equals to 0. So here we have plus 2 and we have minus 2. So this cancels with this. So we are left with k x squared plus 4x plus k is equals to 0. So we realize that this resulting quadratic equation is in the form of a x squared plus bx plus c is equals to 0. Where a, in this case, a is k, b is 4, and c is k. Now, since we have been told that the line meets the curve at exactly 1 point, that means the discriminant will have exactly one solution. That means b squared minus 4ac will be equals to 0. So we said our b is 4, so it will be 4 squared minus 4 times k times c is also k is equals to 0. So 4 squared is 16 minus this is 4k squared is equals to 0. Therefore, here 4 is common, so we factor it out. This becomes 4 minus k squared is equals to 0. So we divide both sides by 4. Here we are left with 4 minus k squared is equals to, this is 0. So k squared is equals to 4. Find the root on both sides, and k is equals to plus or minus 2. Now remember, in our question, we were told that k is a positive constant. Therefore, we consider the positive only. So k is equals to 2. Now, since we've solved for part A, which is the value of k, part B, we were told if the value, using the value of k, find the coordinates of the point of intersection. So with k is equals to 2, so for k is equals to 2, we are going to substitute k into our original quadratic equation which was kx squared plus 4x plus k is equals to 0. So where there is k, you put 2, so it will be 2x squared plus 4x plus 2 is equals to 0. We need to make the coefficient of x squared to be 1, so we divide everything by 2. We shall have x squared plus this becomes 2x plus 1 is equals to 0. So 2x is the same as x plus x, so we shall have x squared plus x plus 1 is equals to 0. So let us group them. So in this first group, x is common, we factor it out, so we shall have x into x plus 1, then plus, this is 1 into x plus 1 is equals to 0. As you can see, x plus 1 is common. We also factor it out. We shall have x plus 1, and we are left with x plus 1 is equals to 0. So here it means we shall get two solutions that are the same, which is x is equals to -1. Now, since we've got the x coordinate, we need to substitute this x value into the equation of the line or the linear equation so that we find the y coordinates. The y coordinate. So, y was equals to 2x plus 1. This was the equation of the line. So, y is equals to 2 times -1 plus 1. And therefore, y is equals to 2 times -1 is -2 plus 1. Therefore, y will be equals to -1. So we've got the point of intersection. X is -1 and at y is -1. Therefore, the point of intersection is -1, -1. So that's how you work with a discriminant. Thank you so much for watching. Please do not forget to subscribe to this channel for more amazing videos. Bye.